An unprecedented exercise tested how the agency would react to a solar superflare like the one in 1859, capable of leaving the world offline in minutes. European Space Agency simulates solar storm that could wipe out satellites. Imagine a global blackout in space and on Earth, satellites out of control, GPS down, electronics failing, and power grids collapsing. This was the extreme scenario simulated by engineers at the European Space Agency ESA in Germany. In an unprecedented exercise that tested human capacity to respond to a massive solar storm. The experiment, conducted at the European Space Operations Center (ESOC) in Dar, brought together dozens of engineers and space weather experts to simulate the worst possible nightmare for modern technological infrastructure, a solar superstorm like the one that hit Earth in 1859, known as the Carrington event, the most intense ever recorded. At the time, the planet was still in the telegraph era. Even so, the storm was capable of causing fires on power lines and illuminating the night sky in reddish hues as far away as tropical regions. Countries like Cuba even recorded a... Today, with the world completely dependent on satellites, the internet, and electrical systems, a similar event would have catastrophic impacts. And this is exactly the kind of scenario the ESA wants to avoid. Lead-toxic heavy metal affects children in Brazil and around the world decades after the ban. Solar flare recorded by ESA's Solar Orbiter probe on September 30th, 2024. The event lasted about 15 minutes and released intense radiation, potentially interfering with communications on Earth. An eruption that came with a bang. The exercise was part of the preparation for the launch of Sentinel-1D, Europe's new Earth observation satellite, scheduled for liftoff on November 4th. The test began normally, simulating the satellite's launch and initial operations, with all systems functioning and communications stable. A few minutes later, however, the data began to show glitches and the satellite signal became unstable, as if it had been hit by a powerful solar flare. Get this, a solar flare is an explosion of energy on the sun's surface caused by the disruption of magnetic fields. Within minutes, it heats the plasma to millions of degrees and releases radiation that can interfere with satellites, GPS, and communications on Earth. According to the ESA, the objective of this phase was to compare the team's response to this extreme scenario, in which a simulated solar flare of similar intensity to the largest ever recorded would virtually hit the satellite, causing failures in communication, radar, and navigation systems, exactly as would occur during a real solar storm. Therefore, from this point on, the scenario became more complex. As the scenario progressed, the systems began to respond erratically, simulating the effects of an X-45 class storm, the most powerful type on the scale used to measure the intensity of these flares. In a real event, a flare of this magnitude could cause widespread blackouts in communications and power grids. According to scientists, radiation from such an event would reach Earth in about 8 minutes, leaving virtually no time to react. A solar storm simulation at the ESA Control Center in Germany tested how teams would react to an extreme flare capable of affecting satellites, communications, and navigation systems. A solar storm simulation at the ESA Control Center in Germany tested how teams would react to an extreme flare capable of affecting satellites, communications, and navigation systems. Thus, this phase of the simulation reproduced the effects of a coronal mass ejection, a gigantic cloud of charged particles released by the sun. When one of these clouds hits Earth's magnetic field, it can cause geomagnetic storms, distortions capable of interfering with satellite operation, power grids, and even generating visible auroras at unusual latitudes, as occurred in the 19th century. If such a storm occurs, satellite drag can increase by 400% with local spikes in atmospheric density. This increases the risk of collisions and reduces mission lifespans due to increased fuel consumption. During the exercise, the teams also simulated failures in guidance instruments, signal loss, and errors in the sensors that help satellites stay on track. The idea was to test how the teams would react to simultaneous failures, something that could occur in a real solar storm scenario. The training also included the participation of ESA's Space Weather Office, created in 2022, and the Space Debris Office, which monitors the risk of collisions in orbit. Both helped coordinate responses and assess potential impacts on other missions. The main conclusion is that it's not a question of if this will happen, but when solar risk is increasing. This ESA simulation is part of a series of international exercises being conducted to prepare governments and space agencies for increased solar activity. As the sun goes through cycles of approximately 11 years, the current one, called Cycle 25, is at its peak. According to NASA, the U.S. Space Agency, recent months have seen a higher than expected number of flares. Between 2024 and 2025, more than 10 solar storms classified as severe hit Earth, the most since 2003. These caused auroras in unusual locations, such as France, Germany, and the northern United States. At times, there were temporary disruptions in GPS signals and radio communications, which even affected air and sea routes. To reduce risks, various countries have been strengthening this monitoring and information exchange. The ESA, for example, runs the Space Weather Readiness Program, responsible for simulations like the one conducted in Germany. NASA, for its part, is developing the Superstorm 2030 plan, which brings together scientists and the U.S. electricity sector to define protective measures for satellites and power grids. Agencies in the United States, Europe, Japan, and Canada also conduct joint rapid response training using data from satellites like Solar Orbiter and SOHO, which observe the sun in real time. These tests help define warning protocols and improve communication between forecast centers. According to experts, the goal is simple: not to be caught off guard. Solar storms are part of the sun's natural behavior, and although most cause only minor disruptions, monitoring agencies want to ensure the world is prepared should a more severe eruption occur again. Extreme solar flare recorded in 2003 by the SOHO Observatory. The explosion, 28 times more powerful than a typical X-class flare, launched billions of tons of plasma at more than 8 million km/h into space.